Welcome to Algebra, Trinomial Factoring Part 2, when the value of a is greater than 1. We'll first demonstrate the traditional guess and check process, listing all the possible factor combinations until finding the one that works. And then we'll show a really cool, much easier method as an option. You have to check this out. At the end of the last video, we examined a trinomial with an a value greater than 1, 2 in this case. Fortunately, we were able to factor out that value, which made the factoring process fairly straightforward, as you can see by the results shown here. What about when there is an a value greater than 1 that cannot be factored out? Like this one, 2x squared plus 7x plus 6. There is no common factor for all three terms 2, 7, and 6, and so we must find two binomials that will work in this more complex situation without factoring out a value. The technique we've followed so far, listing all the different possible factors and finding the right ones using the systematic guess and check method, trying all possibilities until one works, is certainly a process we can follow. The only way to achieve 2x squared is using x and 2x as the factors, and so we list those first. Now we consider the factors of 6, starting with 1 and 6. We have two products to consider, the product of the outer factors, 1 and 6, and of the inner factors, 1 and 2. The sum of these two products form the middle term adding up to 8x, which is not what is needed. Here is where the complexity of this process increases. Before we move on to the other factors of 6, we must now reverse the factors of 6 and check that combination, with 1 times 1 being the product of the outer terms and 6 times 2 the product of the inner terms, adding up to 13x for the middle term, also not what we need. Now we try the other factors of 6, 3 and 2. Check out the outer and inner products of 2x and 6x, which total 8x, still not what is needed. We reverse the order of those factors, listing 2, then 3, and we achieve an outer product of 3x, an inner product of 4x, which adds up to 7x, the correct value of the middle term. Now, there is another way to do this, a really cool process that is very easy to do, with no guesswork involved. Here we go. First, make sure nothing can be factored out of the coefficients. If it can, do that first. In this case, as we saw before, nothing can be factored out, and so we begin the process. This will seem strange at first, but it works. First, take the a value and multiply times the third term, the c value, removing a from the first term. In this case, 2 times 6 is 12, and we now have the trinomial x squared plus 7x plus 12. Next, factor this using the process you learned in the last video, and we get the binomials x plus 3 and x plus 4. Next, divide the two constant values by 2, the original value of a, and then reduce the two fractions if possible. In this case, 3 over 2 cannot reduce, but 4 over 2 can, and we get 2 over 1 as the fraction. Now comes the cool part. The final step is to take the denominator of each fraction and move it in front of the x term for each binomial. We now have the two binomials that are factors of our original trinomial, 2x plus 3 and x plus 2. This process is pretty crazy, but it works. Here's another one that works with this new method, 12x squared plus 17x plus 6. We first check to make sure nothing can be factored out of the three values 12, 17, and 6, and nothing can, so we begin the process. First, multiply the a value 12 times the c value 6 to get 72, and our new trinomial is x squared plus 17x plus 72. We factor this into the binomials x plus 8 and x plus 9. We then divide both values 8 and 9 by the original a value 12, creating the two fractions 8 over 12 and 9 over 12. Both can be simplified with 2 over 3 and 3 over 4 as the reduced fractions. We then move the coefficients to the front of each binomial, resulting in 3x plus 2 and 4x plus 3, the correct factorization of this trinomial. You can see another demonstration of this exact problem solution in this really neat YouTube video featuring Mr. H. Check it out, as well as many others he has produced on his channel. Let's try another one. This time, one that does have a value that can be factored out. The value 2 can be factored out of the values 4, 14, and 6, leaving 2x squared plus 7x plus 3 to be factored. We use our process, multiplying the a value 2 times the c value 3 with a new trinomial x squared plus 7x plus 6. This factors to be x plus 1 and x plus 6. And then we create two fractions using the a value 2, resulting in 1/2, which cannot be reduced, and 6 over 2, which reduces to 3 over 1. We move the denominator values in front of the x terms to get our two binomials 2x plus 1 and x plus 3, which, when multiplied by the original factored out value 2, produces our original trinomial. Finally, let's do one with a negative third term, where one of the binomials will have subtraction as the operator. We again check to make sure nothing can be factored out, and that is indeed the case with 5, 13, and negative 6. No common factors for these values. We first multiply the a value 5 times the c value negative 6, and our new trinomial is x squared plus 13x minus 30. We factor this to get x plus 15 and x minus 2 as our two binomials. Set 15 and negative 2 as fractions over 5. Reduce the 15 over 5 to 3 over 1. Leave the 2 over 5 as is, since it cannot simplify. And then move the denominators in front of the x terms to get x plus 3 and 5x minus 2 as the binomials for this problem.